We're going to remind ourselves about the structure of ionic substances in order for us to be able to then think about electrolysis of ionic substances. So we think of an ionic substance as being a crystalline substance, which means that it's ordered and got a regularly repeating structure. So we often see this shown as a lattice structure, where we've got ions of opposite charges arranged in a regular pattern. Now I'm drawing this in 2 dimensions, but the cube above it should try and remind us that it is actually a 3-dimensional structure. So we describe this as an ionic lattice. It's a regularly repeating structure, and it should be in 3 dimensions. We also need to remind ourselves that we've got strong electrostatic forces holding the ions together. So strong electrostatic forces between these ions. That means lots of energy is needed to overcome these. And as a result of that, ionic substances have generally very high melting points. There are some exceptions, but generally very high melting points, well above 500-600 degrees Celsius, often into the thousands. So the important thing that this links into our electrolysis is that in order for us to carry out electrolysis, we need to overcome these forces. We either need to melt our ionic substance, or we need to make it an aqueous substance. So I'm going to think about both of those options, which achieve the same end. So molten means liquid or melted, and we use it for substances that have high melting points. So the word molten we use for something that has a high melting point. So I'm going to draw this substance a little bit more differently now, so slightly quicker. So I'm not drawing the Na plus and Cl minuses, but what I'm trying to emphasize here is that when we melt an ionic substance, this structure breaks down to some extent. The ions still touch, but very importantly, the ions are able to move. Whereas in a solid, they're locked in position and they just vibrate, the ions are able to move relatively freely in an ionic substance. In a molten ionic substance. Now, the other way to achieve this is by dissolving an ionic substance in water, and the word we use for that is aqueous, A-Q-U-E-O-U-S, which has the state symbol AQ in brackets. Now what happens here is the structure is broken down, but this time in between all of the ions we've got lots and lots of water molecules. Now the way I've drawn this is it might be indicating that there are gaps. There actually aren't. It's just an easier way for us to think about this and to visualize it. But we've got water molecules in between all of the ions, but in reality everything is touching. I've just shown this to make it a little bit easier for us to visualize. And again, very importantly, as earlier, in both when we've melted or made an ionic substance molten, or when we've dissolved it in water, the ions are able to move.